the topic factorization in algebra. Okay, there are different types of questions in factorization. Okay, so I'm starting from the basic. What is factorization? Factorization means getting factors of a given expression. Okay, before that, let us consider if you're finding the factors of 12. Okay, so think about all those numbers which can divide 12. 2, 6, then we have 2 3's. Okay, that means the numbers which can divide 12, 2, 3, 6, 4, all are factors. Okay, and getting these numbers is called factorization. Okay, but this is entirely different from algebraic factorization. Okay, but the concept is same in both the cases. So let us consider factorization. We are discussing type 1, the first basic types of questions which come in factorization. Okay, suppose we have an expression 8x cube plus 12x square y square. Okay, so you can observe there are only two terms, and in these two terms, what are the factors? The factors which can divide the entire expression, right? So you observe, first of all, let us take the coefficients 8 and 12. The highest common number, that is highest common factor, which can divide 8 and 12 is 4. So you take 4 outside the bracket. Now come to the variables. What are variables? X and y are variables. In x cube and x square, pick up the lowest power. So x square we are taking common. Again, observe here there is no y term, but here there is only y square. So they should be common for both. So this is much we can take the factorization. Now, what are the terms which are going to come inside the bracket? The terms which are going to come inside the bracket will be result of dividing this by this. So 8x cube divided by 4x square, we are getting only 2x plus 12x square y square divided by 4x square, that comes to 3y square. So these are the factors. Okay. Similarly, let us observe a second pattern, 8x cube minus 6x square plus 10x. Okay, this is a trinomial. Now think of a highest common factor that can divide these three numbers, and the answer is very simple, 2. Okay, now there is x cube, x square, x. Pick up the lowest power, that is x. Keep it outside the bracket. Now dividing this by this, we get 4, then x square minus, here we have 3x, then we have plus 10x divided by 2x, that is 5. So this is the result. That means the factors are 2x and this whole expression that can divide this. Sometimes you might be feeling doubt whether the terms are okay or not. You can check it. Just multiply this by this expression, you are going to get this result. 2x into 4x square, that is 8x cube, plus into minus is minus, 2, 3, 6, x square, then plus into plus, 2x into 5, 10x. So the result is okay. I hope this is clear for type 1 questions. Then we have type 2 questions. See, when the questions are given in the exams, you must try to recognize what are the expressions related to, whether it is of type 1, type 2, type 3. This type 1 is going to be applied throughout the chapter. Okay. Now, type 2 questions. This is called grouping. Okay. Grouping means there are even number of terms like 4 terms, 8 terms, 6 terms. Okay. Look at this expression. Question number 1. We have x square plus xy minus x minus y. Okay. Now take pair of numbers like this. In this pair we have x common, pull it outside the bracket, we are left with x plus y. Okay, then place minus sign. This is the third sign, first, second, third. This will never change in factorization. Okay, then If nothing is common, take one common. Then we have x minus into minus plus. Please observe, the sequence should be same. If you are getting x plus y, here also x plus y. The sign, the numbers, the sequence all should be same inside the bracket. Now take this common bracket outside, that is x plus y, and the expression outside the bracket x minus y. So these are the factors. Let's take one more example. Now we have x square plus xy within bracket 1 plus y, then we have plus y cube. Okay, so you can see that this expression needs to open the bracket. Okay, now open the bracket, xy into this becomes xy, then xy into this becomes plus xy square plus y cube. Is that clear? Now again we have four terms, same as above. So pick up x common in this, we have x plus y plus, now this is the third sign which I am not going to change. Then pick y square because that is the lowest power in these two. So you have x plus y. Okay. Now take the common factor, place it here, and then the term outside the bracket, that is x plus y square. So these are the factors. Okay. Let me write the question once again. This is 3ax minus 6ay minus 8by plus 4bx. Okay. In this pair, you take 3 outside the bracket. Okay. A will be also coming. So 3a within bracket, it is x minus 2y. Okay. 3ax minus 6ay. Then put minus sign. Here we take 4 common along with b. Okay. This time we are getting 2y minus x. Okay. I especially wanted to discuss this question because here you see the sequence is not coming in the same order. Now what to do in that situation? Logically, if you want to change the sign, if you want to place it in the same order x minus 2y, you change the sign of this, put plus sign over here, automatically the order reverses. Because you don't have to waste time again grouping these two numbers, putting in the order. How did you know that? So if you have written this, okay, don't need to worry. In the next step, you take it like this: 3a x minus 2y. Place the sign opposite. If it is minus, it will become plus. If it is plus, it will become minus. Don't change the term here 4b and reverse this order: x minus 2y, which is same as this. Now take the common factor x minus 2y, okay, and 3a plus 4b. Okay, so this is the result. Now we are going to discuss type 3 questions. This is factorization by difference of squares. Okay. Suppose we take one example: a whole square minus b whole square. Okay. So this can be expressed as a whole square minus b whole square. Okay. Make sure there is nothing common in this. If there is anything common, do it by this method. Okay. If nothing is common, they are perfect squares, then go ahead, write a plus b, first term plus second term, and then first term minus second term. The order of presentation could be different. You can write a minus b first, a plus b next, that doesn't matter. This is the standard type. Suppose in this type, we are going to discuss one question: 9x square minus 16y square. Now you can observe that there is nothing common in both the expressions, but they are perfect squares. So now you can write it as 3x whole square minus 4y whole square. Okay. Now this is first term square minus second term square. Write it 3x plus 4y. Okay. And 3x minus 4y. So this is the expression. Okay. Now let us consider second type question. Suppose it is 9x square minus 36y square, right? Now you see both are perfect squares, okay? But before that, as I told you, this is the basic pattern to be observed. If there is anything common, you pull it outside the bracket. You can see 9 is common. 9 can divide both the expressions. So take 9 outside the bracket. We are left with x square minus 4y square. Now you can recognize the terms inside the bracket. They are perfectly matching with the standard expression. Both are perfect square with a negative sign in between. So keeping 9 outside the bracket, now you can write x whole square minus 2y whole square. Okay. Now keeping 9 outside the bracket, as usual, express the factors inside which are in the form difference of squares. So this is the expression, right? Now you can remove the box bracket, that is 9. Directly you can write x plus 2y, then x minus 2y. Okay? See, this is the most important topic in factorization, difference of squares. Okay? Now let us take one more example. 3 minus 48y square. Okay? You can see none of the terms are perfect squares, but there is something which can be taken common in both the expressions, that is 3. So take it 3 outside the bracket. Always think factorization whether this type is available. That means throughout the terms, are there any numbers which could be taken common? Yes, in this question 3 is common. Now what is left? 1 minus 16y square. Okay. Keeping 3 outside the bracket, now you can write 1 whole square minus 4y whole square. Okay. So keeping 3 outside the bracket, the terms are 1 plus 4y and 1 minus 4y. Okay. Next, let us take one more question. Here we have an expression 25 x plus y whole square minus 36 a plus b whole square. No doubt these are perfect squares, okay, but this is a bit different compared to this and this, okay, but we are discussing these questions under this type, difference of squares, okay, type 3. Now what you have to do, you have observed that nothing is common in this expression, but they are perfect squares. So let's write 25 as 5 square within bracket x plus y whole square minus this is 6 square a plus b whole square. Okay. Now insert 5, multiplying 5 inside the bracket, but no, don't open the bracket. So we have 5x plus 5y whole square minus, insert 6 over here, this is 6a plus 6b whole square. Okay, because see a square b square can be written as ab whole square. This is what precisely we have done for this question. Okay, now we observe that this is in the form a whole square minus b whole square, the same expression what we have written here. So let's now write it as a plus b. This term is, whole expression is a. Okay, so this is a. When you are adding plus b, don't change the sign of these terms, so it will be 6a plus 6b, right? Now you are writing a minus b, again a, that is 5x plus 5y, minus sign when you are writing, please change the sign of these two. So it will be minus 6a minus 6b. Now you think whether you can simplify these terms. Is there any possibility of adding subtraction? If no, then this is the final answer. Okay. Now we are going to discuss under the difference of squares. Okay. We are going to discuss here. This is another type question which is a bit complicated, but again it is in the form a square minus b square. Now you can express this as a square whole square minus b square whole square. So we are going to write it as a square plus b square, then a square minus b square. Okay, but this is not the final answer, because this expression can be still broken as a difference of squares. So keeping this, because a square plus b square is not factorizable, so inside this bracket you write a whole square minus b whole square. Okay, so the ultimate expression is a square plus b square into a plus b into a minus b. Okay, next move this to a little big level, a higher level, that is a power 8 minus b power 8. Okay, even this can be written as a4 whole square minus b4 whole square. Okay, now since this is the form a square minus b square, where a is a power 4 and b is b power 4, so once you are going to add a4 plus b4, and again you are going to express it as a4 minus b4. Now this can't be factorizable. Now inside the bracket you have to factorize this the same way as you did this question. Okay, so it is a square whole square minus b square whole square. So this is a4 plus b4, and we have a square plus b square and a square minus b square. Still this can be expressed as a plus b, a minus b. So I am directly expressing the final expression, that is a4 plus b4 into a square plus b square multiplied by the factors of this, as we have just seen over here. It is a plus b and a minus b. So this is the answer. Okay, even we can apply these terms in arithmetic factorization. Suppose we have a question that 3.7 whole square minus 2.3 whole square. Okay, so you don't expect that you are going to multiply this decimals, square it, and then get subtraction. Observe, this is the same expression as we have done here. So consider this as a, this as b. So the factors are a plus b, a minus b. So you can write it as 3.7 plus 2.3 into 3.7 minus 2.3. Okay, so answer for this result is 6 into this result is 1.4. Okay, so that comes to 8.4. Such a simple result could not be expected without factorization, but remember, the chapter doesn't end over here. You may come across these type of questions several ways, several chapters. Okay, so don't expect that this is a portion of a single term examination. Okay, you will be applying this throughout, even in class 9, even in class 10. Okay, these applications will keep on coming. Clear? Now we are going to express the third pattern of factorization, that is type 4. This type 4 involves factorization by trinomial. That is, there are three terms in this, so it is called trinomial. Factorization of trinomial. This is also called middle term expression, because there are three terms. Look at this expression: x square plus 8x plus 15. Okay, These three terms are there. You have to break the middle term. Don't disturb the first term, third term. Now how to break the middle term? How do you know it will be 1x plus 7x or 2x plus 6x or 3x plus 5x like that? So first multiply the coefficient. I mean, this is the constant term. This is the constant term multiplied by the coefficient of x square. The coefficient of x square is 1. So 15, that is the constant term free of x, and this is x square coefficient, that is 1. 15 into 1 is 15. Get the prime factors of 15. 3 5s. Please show this working on the right hand column of your answer sheet. Okay. Now you got the two terms without disturbing the first term and the third term. Not even the sign. Break up this as a sum of two numbers. So it is 3x plus 5x. Okay. So again I am telling you, we have not disturbed the first term, third term, neither their position nor their sign. We have just broken the middle term as a sum of two numbers by this method. Okay. Now after this you have to proceed the same way as we did for grouping. So these are the four terms. In the first pair you take x common, we are left with x plus 3, then 5 common, x plus 3. Okay. Take the common factor first, x plus 3, and then we have x plus 5. So this is the answer. Okay. X plus 3 and x plus 5. Let us take one more example. Here we have, suppose a whole square plus, let us take a complicated question. Suppose this is a plus 3 whole square, okay, plus 8 times a plus 3 plus 15. Okay. I have just made this question a little bit complicated. Okay. Normally what the children do, they start expanding this. It takes a lengthy process. Now what you have to do, you have to substitute this value. How do you know you have to substitute the value? You can see the binomial term is repeating. Here it is repeating, raised to the power 2, here it is along with 8. So twice it is getting repeated. So let a plus 3 equal to x. You assume those value only which is not given in the expression. Suppose the expression is in terms of x. Now here in the same question, you can't take a plus 3 as a. So pick up any other alphabet, x, y, z, like that. Now putting the value of x here, okay, we have x square plus 8x plus 15. Okay. Again get the factors. 15 into 1 is 15 and the prime factors are 3 and 5. So break this expression, 8x square plus 3x plus 5x plus 15. Okay. Then take the factors by grouping method. So the factors are x plus 3 and x plus 5. But this is not the complete answer. Why you know? You have assumed x. The question doesn't contain any x terms. So again resubstitute the value. That means put the value of x. What is it? A plus 3. So this is a plus 3 plus 3 and a plus 3 plus 5. Then simplify. This is a plus 6 and this is a plus 8. So this is the final answer. Okay. Hello students. We have already observed the different types of factorization. Okay. We began the chapter from the basic expression, that is an algebraic expression was given in which we found few terms, numbers and variables common. So we put it outside, took out common. This was simple factorization. Perhaps this will be applied in all the concepts of factorization. Okay. Second, we observed factorization by grouping. Okay. Here we had even number of terms, 4 terms, as you can see in this expression. Then there could be 6 terms, 8 terms. Okay. That is how you can observe which method you are going to proceed. Okay. Then we took the third type, that is factorization of difference of squares, that is a square minus b square pattern. Okay. So we have got these factors a plus b, a minus b, and slightly gradually we move to next level. Then we discussed few types of questions. Okay, all of which were based on difference of squares. See, there are different types. Clear? Here we found factorization by trinomial, that is there are three terms. It's also called middle term factorization because here the middle term has to be split up into sum of two numbers, and that's only possible by this method, taking prime factors, and then you have to observe hidden trial. Again we came to factorization by taking substitution method. This is called substitution method. Okay, because the values which are repeating, they are getting replaced by some other expression. Okay, like here a plus 3 is repeating, so we took a plus 3 is equal to x. Now these are the basic type of questions meant for beginners, that is class 8 and even class 9 students. Okay, now we are moving to next level of factorization, a bit tough questions which is meant for only class 9 students. Okay, now look at this question based on trinomial. Suppose we are given this type of expression, 16x square plus 24xy plus 9y square. Okay, this is also a trinomial, but this can be factorized by the method of expansion. Let me write by method of expansion. Okay, now look at this expression. If you observe this, there are two square terms. Okay, this is not always possible in factorization by trinomial, only for this type of questions. Okay, now you express this as 4x whole square, this as 3y whole square. So you know the square of 4x, you know the square of 3y, so these are perfect squares. Now this is a middle term, that is 2ab, where a is this, b is this. So you can observe this by putting the value of a and b, exactly you will be getting the middle term, 2 into 4x into 3y. Yes, we got 24xy. So this can be expressed as a plus b whole square. That means the factors are 4x plus 3y, 4x plus 3y. Okay, so already you have done expansions of binomial having the raised to the power 2, that is a plus b whole square. So a plus b whole square equal to a square plus 2ab plus b square. Okay, so I am discussing this method because now you are getting some complicated questions based on difference of squares, especially in class 9. Okay, now let us observe one question. Suppose we have an expression 16a square minus, okay, inside the bracket we have, suppose 9x square plus 24xy plus, suppose this is 16y square. Okay, now the question is based on difference of squares, but you don't know that this is a perfect square like this. Okay, so you need to factorize this by expansion method. Okay, so this is 16a square minus, now this can be written as 3x whole square plus this is 4y whole square, and this is 2 times a into b. Okay, so you got the exact result as we did here. Now this can be written as 16a square minus, directly you can write this as a plus b whole square because 2ab term is positive. Now you observe that this is coming in the form a square minus b square, that is 4a whole square minus 3x plus 4y. Sorry. Now this is a whole square minus b whole square. We can write a plus b, and a, when you are putting minus sign, please change the sign of these two numbers, 3x minus 4y. So this is which you might be facing. Okay, let's take one more example. Well, this was a very easy question. You could easily recognize this as a perfect square, that is a plus b whole square. Now we are giving a little bit complicated question based on difference of squares. As I told you, the most important type of factorization is difference of squares. Okay. Now one more question I am giving you. 9 minus x square plus 2xy minus y square. Okay. You write this expression, right? Now please observe this question. Pick up the like terms, unlike terms. Okay. This whole expression is 1. This is unlike term. So you take it inside the bracket. 9 minus, if you insert inside the bracket, all the signs will be opposite. This will become x square minus 2xy plus y square, right? So this question is not so easy as this. Okay, you have to decide first which three terms will be taken one side and which the left out term will be taken as a different expression. So keeping 9 outside the bracket, inside we can factorize this. This is already in the form x minus y whole square. Okay, now we can express it as 3 whole square minus, this will be expressed as x minus y whole square. So it is in the form a square minus b square. Once you add, when you are adding this, don't change the sign of these numbers inside the bracket, and when you are subtracting 3 minus sign, that is a minus b, then change the sign of these two numbers, it will be minus x plus y. So this is the result. Okay, now we are moving to next pattern of questions. Look at this question. This is the most complicated type of questions in difference of squares. Here we have x square plus 1 by x square minus 11, right? Now this question needs special attention. You are having two square terms, okay? So you can express it as x whole square plus 1 by x whole square. Okay, to finish this expression, to make it a perfect square, we need 2 into x into 1 by x. Okay, or we need minus 2 into x into 1 by x. That means either it can be made a plus b whole square or a minus b whole square. But what to do with this minus 11? Okay, see, this you have made it possible addition. Okay, this is a hit and trial method. Now you have to decide which of the two expressions will fit over here. Because you are adding this term, subtract it from this. This is called adding and subtraction method. I repeat once again. To make these two perfect square, a complete expression a plus b whole square, we are making this possible or this possible. Okay, but this minus 11 is there. Okay, suppose to make it a perfect square, you are adding this expression, that is plus 2. Then you have to subtract minus 2 over here. If you add plus 2 over here, it makes a complete expression a plus b whole square. But here minus 13 cannot be expressed as a perfect square. So this is not admissible. Now think of this. A square plus b square minus 2ab. That means you are adding minus 2 to this to make a perfect square. Then what you need? Here minus 11, you have to add plus 2. This is also called adding or subtraction method. Okay. So when you subtracted 2 from this to make it a perfect square and adding the same expression 2 to this, now you are getting this as perfect square. Minus 11 plus 2 is 9. So this is admissible. So you are going to pick up this expression. Okay. That means x square plus 1 by x square minus 2, and here minus 11 plus 2. Okay. This is also called adding subtraction method. Whatever number you subtract, add the same number to the third expression left out. And if you add over here, subtract minus 2 from this. This is called adding subtraction method. So now this is in the form x minus 1 by x whole square, and here minus 9 is left, which can be expressed as 3 whole square. So the ultimate factors are x minus 1 by x plus 3 and x minus 1 by x minus 3. Okay, this is the complete factorization. Let us take one more example. Okay, this is called adding and subtracting method. So what is adding and what is subtracting, that we have seen by hidden trial expression. Let's take one more example. A to the power 4 plus b to the power 4 plus a square b square. Okay, again you observe two square terms here. Can be written as a square whole square plus b square whole square plus. Now you write this plus a square b square here. Okay, to make it a perfect square, you can add plus 2a square b square. Okay, but the same has to be subtracted here, minus 2a square b square. Okay, adding subtraction method. Now check it. Are you comfortable with this expression to continue further? Let us put the second test, minus 2a square b square. Then also it becomes a perfect square. But here what happens? With a square b square, the third expression given in the question, here if you subtract, here you have to add. Okay, well this is not permissible because it is coming 3a square b square, which is not a perfect square. So this is giving you a perfect match for this expression. That means here you are getting minus a square b square, which is expressed as ab whole square. That's a perfect square. So select this. Therefore this is sometimes called hit and try method. Now we are left with a square whole square plus b square whole square plus 2a square b square. This is the final expression, and here we have minus a square b square. Okay, so this is completely a square plus b square whole square minus, now this is ab whole square. Okay, so now you can see it is difference of two squares, a whole square minus b whole square type. So you are writing now a, that is first term, plus this ab, and then we have a square plus b square minus ab. So this is the result. So this is the most important type of difference of squares. Okay, so this is specially recommended for students who are in class 9. Okay, now we are coming to the next level of factorization, that is factorization of a cube plus b cube. Okay, now this is type 5 question pattern of factorization. Sum of cubes, let me write now, sum of cubes and difference of cubes. Clear? So this is the question and the factors of this are, first you are writing as a sum of two cubes. Let it be very clear. Even if there is something common, you take it outside. After that, you proceed. Now, this is a plus b. The first factor is a plus b, and the second factor is a square minus ab plus b square. Okay? So, these are the factors of a cube plus b cube. Second, if we have a cube minus b cube can be expressed as a whole cube minus b whole cube. So we are left with factors a minus b with a square plus ab. Please observe the difference, okay? Plus b square, okay? So if it is a cube minus b cube, the first factor will be a minus b. If it is a cube plus b cube, the first factor will be a plus b, okay? And the difference will be, here it will be minus ab, opposite of this sign. Here it is plus ab, opposite of this sign. Now let's proceed solving one question. Suppose we have an expression a cube plus 27b cube. Nothing is common in this, and you are observing that they are perfect cubes. So you can proceed like this: a whole cube plus b whole cube. Okay. Now this can be written as, this is 3b whole cube. Okay. Now we can write it as a plus 3b as per this formula, and then we have first term square minus first term into second term plus second term square over. Now simplification: a plus 3b into, this is a square minus 3ab plus 27b cube. Okay. So these are the factors. This is a simple expression in this pattern, a cube plus b cube. Similarly, there could be a question like this: 8x cube minus 27b cube. We can write this as 2x whole cube minus 3b whole cube. After you confirm that nothing is common in these two expressions, then only you proceed in this pattern. Okay? Then you are going to write it as a minus b, that is 2x minus 3b into first term square. Here the sign will be plus first term into second term, okay, plus second term square, bracket close. So the term 2x minus 3b is there into, this is 4x square plus 6xb plus, this is 9b whole square. So this is the expression. Okay. Now let us take a bit complicated question like a6 minus b6. Now first you have to decide whether to write it as a square whole cube minus b square whole cube, okay, or to express it in the form a cube whole square minus b cube whole square. Now let me tell you the demerit of one of them. Okay, don't proceed by this method because you need to proceed in later part of this question a calculated step. A perfect expression will not come here, but here it is perfect expression coming without any problem. Let's compare. Here we are going to write a square minus b square pattern. So it is a plus b, okay, that is a cube plus b cube into a cube minus b cube. Okay. After this you can proceed. You can write the direct formula, that is a plus b, a square minus ab plus b square. Okay. And here we have a minus b into a square plus ab plus b square. Right. So this ends the calculation, but here it is not so simple. So be perfect in selecting what should be the exact process. Now if you factorize this expression, By applying a cube minus b cube, we have a minus b, that is a square minus b square. Okay, here a is a square, b is b square. And then we have to write it as first term whole square plus first term into second term plus second term whole square. Okay. Now after this, the terms, the factors of this will be a plus b into a minus b. Then if you simplify this expression, you get a4 plus a square b square plus b4. Okay. If you complete the steps here itself, then this is incomplete because this term is still factorizable. Factorization means you have to complete the expression. If you leave these type of expression incomplete form, you might be losing marks. So what you have to do with this, again you have to do by adding subtraction method, which you have done in factorization by difference of squares. That means the method becomes more lengthy, and such type of questions put you a lot of stress in the exams. So this will be a plus b into a minus b. Then you have to do like this. This is a square b square plus b square b4 plus a4. Okay, keeping a plus b, a minus b. Here you have to do a4 plus b4 plus, to make it as 2a square b square, you have to add a square b square, the third expression, with another term a square b square. Okay, and then subtract the same. This is adding subtraction method. So what I have done, I have made this expression as a perfect square by adding a square b square to the already existing a square b square. So this makes me a perfect square, and because I have added a square b square, I am going to subtract the same at the last. So cancelling these two expressions, the expression becomes the same. But all this, it should strike your mind. So better you proceed by this method. Now for this, it is a plus b into a minus b within bracket. Now the expression for this is a square plus b square whole square minus this is ab whole square. So in the next step, you can write this as a square plus b square plus ab and a square plus b square minus ab. Okay, with these factors which are continuing, a plus b, a minus b. So the result is same as for this, but just expect that if this method you are going to do, either you will stop here or you won't proceed after this. Okay, so I would recommend this is the simplest method because it all depends how you handle the question. Okay.